Okay, I just want to do one more example for a confidence interval for a single proportion. So after his first 2 games, so there's only 2 games of data that we're looking at. So his sample only comes from 2 different games. In 2009, 2010, NBA superstar Kobe Bryant had 45 shot attempts and made 17. So that means that out of the sample, his total N is 45, and the number of successes that he has is 17. Okay, so it asks, what is your best guess of Kobe's true proportion of shot attempts in the 2009 to 2010 regular season? So another name for the best guess of somebody's true proportion or true parameter, whatever that may be, is also that single value estimate. So what I'm actually trying to calculate here is the single value estimate. So just to recall what our single proportion confidence interval is p hat plus or minus 2 times the square root of p hat 1 minus p hat all over n. Okay, so remember the p hat is the number in front of the plus or minus, which is also the single value estimate. So the p hat represents the single value estimate, and everything thereafter represents the margin of error. So all of this stuff right here is the margin of error. Okay, so if we want to see what his best guess or single value estimate is for the 2009-2010 season, we're going to try to find his p hat, which is the number of successes over the total number of attempts. So in this case, it's 17 over 45. So his single value estimate, or his best guess at what he's doing, is 0.378. Okay, so real quick, what I want to do is talk about what this 1 minus p hat might represent. So if p hat represents the proportion of successes, what would 1 minus the proportion of successes be? Well, that 1 minus p hat is actually the proportion of failures. It's the proportion of failures. So now we're ready. We have everything we need. We have n is 45. Our p hat is equal to 0.378. And we're ready to just use the formula to find our confidence interval. So 0.378 plus or minus 2 times the square root of 0.378 times 1 minus 0.378 all over your n value, which is 45. Okay, ultimately you put the square root of everything into your calculator, you'll get 0.378 plus or minus 2 times 0.072. Oops, that's 2. So 0.072, you'll get 0.378 plus or minus 0.144. So be careful when you're putting these things in your calculator. Try not to round until the very end. So if you round somewhere, like say, for example, you round when you do the division, and then you round again when you do the square root, and then you round a third time when you multiply by 2. You're just going to get some hundredth of a value or even like a tenth of a value off. So make sure that you're not rounding until the very end. Okay, so if I do 0.378 minus 0.144, that's going to give me the lower boundary of my confidence interval, which is 0.234. And then if I do 0.378 plus 0.144, okay, that's going to give me the upper boundary of my confidence interval. So that means that Kobe Bryant's true proportion of shot attempts, so for making a shot, is somewhere between 0.234 and 0.522. Okay, so now that we've calculated the confidence interval, you're ready to interpret, which hopefully by now, after seeing it multiple times, you're kind of getting the hang of interpreting the confidence interval. So we always start with, we are 95% confident. So we are 95% confident that the interval of plausible values from 0.2, whoa, that was ugly, from 0.234 to 0.522 contains Kobe's true proportion to make a shot in the 2009 to 2010 regular season. And the more specific that you are in this interpret, the better off you'll be. Okay? So what do you think would happen if we were to look at the entire season and not just 2 games? So if we actually, instead of 45, if we increase this n, what would happen to our confidence interval? So increasing n would decrease the margin of error. Okay, so then your confidence interval would be smaller. Okay, so if you ever increase your n, that's going to decrease the margin of error and create that smaller confidence interval that's getting closer and closer and closer to what we think is the true proportion. I want to ask a couple questions. We haven't talked about these too much. So let's look back at what this confidence interval is. So it's 0.234 to 0.522. Okay, so I just took a moment to write the confidence interval that we calculated for Kobe Bryant's true proportion to get a shot. So there's some questions that I could ask you, such as, are you convinced that his true proportion is? So let's say, are you convinced that it could be 0.325? Okay, so if it's 0.325, what you have to do is you have to look inside the confidence interval and see if 0.325 is inside the confidence interval. So instead of is, let's change this to could be. Okay, because we don't know exactly what the value is, but we think it's somewhere in between this interval. So are we convinced that his true proportion could be 0.325? I'd say yes, because 0.325 is within the interval. Okay, and then I'm going to ask maybe a different way. Are you convinced that his true proportion is greater than 0.116? So 0.116 would be to the left of the interval. So if I calculated with 95% confidence that his true proportion is in between these two values, then I would say yes, because the interval is entirely larger than 0.116. So here's kind of the tricky one. Are we convinced that his true proportion could be less than 0.426? So 0.426 would fall within the interval, within the lower boundary and the upper boundary of the interval. So am I convinced that his true proportion is less than that value? I'd say, while 0.426 and values below are within the interval, there are also cases where his true proportion could be higher than 0.426. So therefore, I'm not convinced. I am not convinced that his true proportion is less than 0.426. Let me think. There, I am not convinced his true proportion is less than 0.426. So anytime that it asks you to look to see if there's values that could be within the interval, or if it asks you if you have evidence that you have a greater true proportion in this case, or if you have evidence that it's a less proportion than this, you're looking to see if those values are within the interval, and you're making your conclusion based off of that. So like in the first one, we could say that its true proportion is 0.325 because it's inside the interval. And we could say that it's greater than 0.116 because the entire interval is greater than 0.116. Now, when it says if it's less than 0.426, you look for where 0.426 is. It's inside the interval, and while there are cases that are lower than 0.426, there's also cases that are higher than 0.426. So we have an interval of values that could be the answer, but we don't necessarily know what the true proportion is.